time we solved this problem, which was great. Everyone had a good time with that. A lot of people in the comments, though, found a sneaky trick to make this a little bit more efficient, right? Because this is a competition problem after all. We're competing. Time is of the essence. So let me show you what that trick is. Last time, after we did our converting, we recognized that all these numbers multiplied together were going to be equal to n factorial. We then split those numbers up into their prime factors and used these prime factors to build our factorial kind of by brute force. But what if we were able to make some key observations about this initial set of numbers that helps us get to a solution a little quicker? And when we're thinking through this problem, in our heads, we're working towards a factorial, right? Something that looks like 1 times 2 times 3 times 4. But at this point in our problem, we don't know where this factorial is going to stop. And so making those key observations about those initial numbers are going to help us figure out, well, does this stop at 6? Is this 6 factorial? Is this 10 factorial? So the observation that a lot of you guys made was that, well, 60 has a factor of 5, and there are two 60s. And so there are two 5s that need to kind of be represented within our factorial. So if you just think about this, right, 5 definitely can't be represented in 1, 2, 3, or 4, but we have a 5 right here. And so we're going to at least have 5 factorial. We have another 5. Well, where next is a 5 going to be represented? Not in 6, 7, 8, or 9, but in 10. So our factorial is at least 10. Then we're thinking, can we have a factorial bigger than 10? Well, if we did, then we would have to have an 11 represented somewhere in these numbers. And we don't directly see an 11, and none of these numbers are divisible by 11. And so there we have it. We know that our factorial has to stop at 10. And so n factorial is equal to 10 factorial. There are 10 factorial seconds in 6 weeks.